All right, class. Hello. All right. Okay. So we're trying, right? Morning to all you people that are. Is it me? Or is it kind of like really humid in here? It's like gross. Can someone hit the fan, please? Someone, please. Thank you. All right. So the derivative as a function. Define the derivative function. Graph the derivative function. Identify where a function has no derivative. A function has no derivative. So find the derivative of a function at a number c. So now it's going to be slightly different from what we have been doing. Slightly different. Okay? But this works out. It works out just the same. Okay? A lot of time for those previous problems, I had a point that I want to find a derivative at, or I want to find the slope at. Now we're actually trying to find the slope, an equation of the slope of the function at any point. So I don't have to do the math every time when it says find it at, c equals 0 or c equals 3 or c equals 5. Now we're going to find it an equation for the derivative, for the slope at any time. So I can just plug in my numbers and that's going to be my slope. So as I do that, this is derivative of the function. So what this means is of f of c, so any point c, okay, so plug in c plus h minus f of c, find the derivative of the function, okay, at any real number c. So at any real number c. So if I were to do that, that means that c plus h is going to get plugged in there, right? So it's going to give me, so the limit, crap. Did everything except for, there we go. Okay, so limit, no, stop it. Okay. Limit as h approaches c of f of, so wherever my x value is, right? Or in this case, it's going to be x approaches, so some value, f of x. So we're going to have, it's going to be, in this case, what is my c value here?
Your h value?
F of?
X squared minus 5.
Yeah, so it's going to be an f and x problem, right? So by looking at this is going to be f of x now, right? Because this function is f of x. And so if I'm looking closely at this is f prime of c, but in this case my c is x, right? So in this case, as h approaches my c value, which is now x. So, change that to x. So I'm going to have f of c, come on, x plus h, right, squared minus 5 times x plus h minus f of c. So now my f of c is just f of x, right? So f of x is going to be x squared, so I'm going to put a parentheses here, minus 5x all over h. Did I lose anyone? Yes? All right. Okay, what's wrong? What did I do? Okay, so this one right here says every place I have an x, I'm going to put in c plus h. But in this case, my c value is x, because that's what I was stating with this information right here. So it's a limit as h approaches x, because this is going to be here. So remember, x is c, right? And so now I put x plus h squared, because it says x squared, right? And then minus 5x, so 5 times x plus h, then minus f of c. Now, this is where everyone is going to make a mistake if you make a basic mistake. So minus, put a parentheses here, because I have to distribute the negative amongst my f of c function. Okay, that's always going to be one of those little things that catch a lot of people. Now, did that help a little bit, or Okay, so we're gonna do it again. We're gonna do it again here in a minute. So I just wanted to make sure you understand what we're doing. So as I square this one over here, I'm gonna get x squared plus 2xh plus h squared minus 5x minus 5h minus x squared plus 5x. All this is going to be over h. So I just expanded that right there, the binomial square. All right, so now let's see. Since I have I'm going to change color on this one. I'm going to have a positive x squared, right? And I have a negative x squared. Okay, those can go away. I also have a minus 5x and a plus 5x, right? So all those will go away, right? That's the whole point of this. All those will go away, so I'm going to be left with 2xh plus h squared, right? Plus h squared minus 5h. Everything is over. So now, what can I do with the top? I can factor out an h, right? So by canceling out those items, I can factor out an h. So I'm left with h quantity of 2x plus h and then minus 5 all over h. And then I can cancel out an h. There we go. Insert page after. So now I'm taking the limit as h goes to x of 2x plus h plus 5 or minus 5? Minus 5?
Yes.
Yeah, minus 5. There we go. All right, so now, what can I do now? Yeah, plug in. So it's going to end up with equals 2x plus h minus 5. So that's going to give me, no, bad. I said plug in. There we go. All right. So I keep saying it, but it's not happening. So it's going to give me 3x minus 5. I don't like that. Because that's not right. It should be 2x minus 5. Did I miss something?
I thought it was like as it approaches 0.
Yeah, it should be, but it's...
No, the math makes sense.
I know, but it should be 2x minus 5, limit as 8. Yeah, I know it should be approaches 0. I might have just made a mistake on the slide. Because I know the derivative, so f prime of x, let me see. So my function was, so f of x equals x squared minus 5x, so the f prime of x is 2x minus 5. So this should be as h goes to 0. So I think I did actually copy this one wrong. Because all the math was right except for the plugging in for that one. Friday, I think you're right there. Yeah, it should go to 0. But let me double check, because there is one type of problem that it could be referring to, but I don't think it is. Nope, Friday's right. Good job, Friday. Okay, good job, Friday. All right, so let me do this again. Back it up. So this part should be as h approaches 0.
Oh yeah, the difference was.
Yeah, it is the difference quotient. So as this goes to 0, that becomes a 0. So my answer should be just 2x minus 5. It should be. But I'm going to teach you guys the easy method super soon, which is just, you don't have to do all that math. You can just go there. So, yes? Huh? No. No. Because the process, the AP exam, requires you to actually do those because they'll give you problems that you can't do this with. So, what's up?
So this answer, this final answer is the derivative of,
F of x should be 2x minus 5.
and what is this mean?
What's what?
What is this answer?
Okay, this means that the derivative at any point of the function could be modeled at that. So if I say, hey, what is the slope at 0? You plug in 0 for the derivative function, and it'd be 2 times 0 minus 5, which would give me a negative 5. So my slope at that point would be negative 5. So if I plug in positive 2, if I plug in positive 2, it's f prime of 2 equals 2 times 2 minus 5, which would give me a slope of negative 1. So that is the slope at any point of the function. Yes?
Then in our last unit, what were we looking for?
You're doing instantaneous for just one point. And you would have to redo the math every time. So like the question I gave you, that I helped you with this morning. Okay, so you did the 140, right?
Yeah.
Then you had to redo the math again at 3. This, you do the math once and you can plug in at any point. So it's slightly different, so yeah. So this one is at all times.
Why don't we just say this?
I know, right? I know. But like I said, I know, yes. That would be me right here. Yes. All right, so okay, so I'm going to change that up. So we're taking the limit as x approaches crap. Because there is a typo on that one. So as h approaches 0, right? H approaches 0 of, and this is going to be x plus h, so it's going to be quantity of right? Yes. So x plus h minus over h. There we go. So now, on this one right here, I cannot plug in the 0 right away, right? So, yes. Cannot plug in 0 right away for this. So, I have to do some creative math. So, as I do some creative math, I'm going to multiply by the conjugate of this one. So, that's going to be interesting. I say conjugate because I have this and a minus sign in between. I'm not just looking at this. So what happens if I multiply by the conjugate here? I'm going to be left with just x plus h, right? And I'm going to be left with just x right here, right? Okay, so the conjugate's going to take care of my radical, right? The square root, or in this case, 1/2 power. I like writing it as 1/2 power all the time because it shows all that. And plus, a lot of times, when you're looking at a function like this, you're not really sure if the number should be inside the radical or outside the radical. So you'll get like a square root of x times x, where you're not sure where it's supposed to be, or square root of x times y, those type of things. So anyway, so I'm going to multiply by the conjugate, which is the quantity of x plus h, 1/2, plus square root of x, right, over so as I distribute that and I multiply by the conjugate, so it's all going to simplify out. So I'm not going to distribute the bottom, I'm just going to leave it. So it's going to end up becoming x plus h, right, because it's this squared, and then it's going to be a minus x, right? All over h quantity of x plus h 1/2 plus x 1/2. Right there. So instead of distributing it all out, I'm just going to leave it. And so what's left on top? So since I have x plus h minus x, that's going to leave me with just h, right? And so that's the reason why I left the h factored out of the denominator. So I'm going to be left with all this. So now I can plug in 0 for my h values. So those are going to cancel, so it's going to be left with 1. So I'm taking the limit as h approaches 0 of 1 over, you know, make it at least, come on, there. Okay, so 1 over, so quantity of x plus h 1/2 plus x 1/2. There we go. So if I plug in 0 for h, it's going to be the x plus 0, right? So it's x to the 1/2 plus x to the 1/2. How many x to the 1/2 do I have? 2. So my answer, as this goes to 0, it is 2x to the 1/2. So what does that mean now? No, it's 1/2 because it's square root of x. Yeah, it's square root of x.
How did we take out, wait, how did we get 1?
How did we get 1? Okay, so on top of this fraction, the numerator, look right here, x plus h and minus x, right? So that's going to be left with just h, isn't it?
Yeah.
And then there was an h right here times all of that. So I was able to get rid of my h's like that.
No, it looks like a K.
What?
Your heads. You don't see the K at all? I said K, not cat.
I heard cat.
Oh.
Oh, okay. Anyway, all right. Interpreted derivative as a rate of change. Interpreted derivative as the rate of change. The surface area S in square meters of a balloon is expanding as a function of time. So I know I'm dealing with surface area, right? Say yes.
Yes.
Okay, good. So surface area, so my function is going to be S of t in terms of time is equal to 5t squared. Find the rate of change of the surface area of the balloon with respect to time. What are the units of S prime? So right now, let's start off with finding the derivative, finding the equation of the derivative. So it's going to be the limit as h goes to 0 of, that's going to be 5 quantity x plus h, t plus h, right? Yeah, let's do t plus h, because I keep putting that. So t plus h squared minus 5t squared over h. All right, so I want you guys to try this. I've set it up for you. I want you guys to try it right now.
It's gonna be hard to see.
Want a different one?
No, that'd be great. Wait, you're not a chemistry test teacher?
you left that in the library like last week.
Oh, library.
Hi. Are you teaching?
Yes.
Really?
They're actually doing a problem right now.
Okay. I saw you.
Yeah. Jesus.
Does that say science? Oh, okay, that's cool. What you, so what you think?
Alright, I'll talk to you later. Alright, so yes, it's right there. Alright, so let's see what we got. So I'm hoping you guys actually were able to expand it so we get 5 quantity t squared plus 2th plus h squared closed minus 5t squared all over h. And so as I distribute, I get 5t squared plus 10th plus 5h squared minus 5t squared all over h. And so when I go through and circle things, I'm going to say that this and this go away, and I can factor out a h, and I'm left with 5h, right? Plus 10th over h, right? I'm taking the limit as h goes to 0, cancel those out, and then, wait, I shouldn't have an h there, right?
Yeah.
That should just be t. And then plug in 0 there for my h, and I should get 10t. So 10t. So now, let's talk about units on this now. So,
10 times.
is this a rate of change?
Yes.
Is this a rate of change?
Yes.
Yes, it is going to be a rate of change. Of what?
Surface area.
Surface area. That's very good, right? So it's changing a surface area, right? And that my units are going to be what?
Square meters.
Square meters for every,
Section.
there we go. And so my rate is going to look like this. So whenever I plug in some number here, it's going to be meters square per second. So that means that if I were to say, hey, at 1 second, I would say, what would I say?
And it's 10.
Expanded.
Yes, it is expanding at a rate at 10 meters per second. At 1 second. So what about at 5 seconds? It would be expanding at a rate of 50 meters per second. Yeah, it is. It doesn't say how big the balloon's going to be, but it's a big one.
Wait, so if this is just like the slope, it's like the rate, at every second it's growing at. What is
It changes, right?
Yeah.
It's not linear. It's not keep growing at a same pace. It's actually, it's getting bigger and bigger and bigger, right? It's going faster and faster and faster. So surface area is growing. So yes, does that answer your question? Anyone else? So graph the function and its derivative. So if this, okay, here's my function. Okay, for the sake of, I'm going to jump straight in, and I'm just going to tell you what it's going to be. So if this is f of x is equal to 3x minus 1, I'm going to say f prime of x is equal to 3x squared. Because I want you guys to have this part right here. Now, this is one of the most complicated parts of this. Is not like understanding. Just to let you know, I struggled with this for such a long time myself.
Now you're really
I did, because I keep thinking a graph is just a graph. It's not. So we have to think about it as two different worlds when we're talking about the graph of the function and then the graph of the derivative. The graph of the derivative just means different things. So I'm going to show you guys here. Now, the blue line is my graph of the function. Yes? Okay. So the blue line is the graph of the function. So I know right here. So from here to here, it is, okay, this is going to be like a 0 right there, right? Okay, so I'm going to end up with the slope of 0. And then right here, it's going to go up, 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 up. Okay? Is this slope always positive?
No.
Except for at 0, right? This one right here. Is it going up?
Yeah.
Up, up, up. Then it goes to 0. Then it goes up, 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 right?
Yeah.
Okay, so now, this is like super, like the big concept here. So at, let's see if I can find a good one. Right here, -2. So at -2, what is my slope?
Yeah.
My slope is, looks like 10, right?
Or 12.
12. Good. Positive 12. So what that means is, right here at this point, if I draw my tangent line right there, the slope of my tangent line is going to be what? 12. Maybe? What is the slope of my line right here? Because the graph dips down to 0, doesn't it? It has 0 slope. It goes up to a 0 right there, right? And so since my green line goes all the way down to 0, that means the slope at this point is 0. And over here, as I keep going, the slope over here is positive again, right? So the slope is positive again. So that means the slope at this point right here is going to be, let me see, that's positive 1, so my slope should be 4. At when x is 1, when x is 1, plug it into my derivative. It's not 4, it's 3, right? Sorry.
Yeah.
Sorry. Okay, so yeah, so it's going to be 3. So it's 1 squared times 3 is 3. So my slope is going to be 3 there. So slope is going to be 3 here. And that's, it's kind of a hard concept to understand because a lot of people have trouble with this part. Questions? Because we're just talking about understanding what the graph of the derivative is. Now, here's a neat cheater trick. This is x cubed, isn't it? And then my derivative is x squared, isn't it? It should always be 1 less. X cubed, x squared.
Oh, yeah.
Watch this. X squared,
X
x to the first, right?
And then if it's linear, then it's just the slope.
X squared, and then just x. All right. Okay, graphing the derivative of the function here and here. Here's a graph of the function shown here. So this is y equals f of x. Is this the derivative?
No.
No. Okay, so now, let's take a look here. If this is just my function, what is happening here? So as my function's going up right here, right? At this point right here, what is the slope? 0, because it's changing from increasing to decreasing. So that slope is 0, right? So at 2, I'm going to put a dot right there. Because I know that the derivative is going to go to 0 here. Now, let's see. On this roller coaster, I'm going from here down to here. So now over here at 3/2. What is the slope at 3/2? 0. There we go. Now, let's talk about behavior here. So, all the way from this point on to the left, what is that graph doing? Look at the graph. Increasing, right? It's increasing, so it's going up, right? It's going up, so that means my slopes have to be, the slopes have to be positive. But if you notice right here, almost when it's getting to 0, doesn't it like level off? So these numbers down here should be greater than these numbers over here, right? So these numbers for this slope should be greater than the slope of right close to it, right? So it's going to look like this. Okay, because it's going to that point, right? It's going to a 0 right there. But now, from this point on, this roller coaster is going down. So if it goes down, what are my slopes?
Negative.
It's going to be negative. So these are all down in the negative now, right? So it's going negative. Let me see. And right here we said it's going back to 0, isn't it? Yes, it went back to 0. So my slope here is 0 now. And so from this point, from 3/2 on, isn't that positive slopes? All the numbers over here should be positive. From this point to the right, every number should be positive as it goes. So yes, it's kind of wonky, but you know what? You guys get the, because I can't trace in very well. Does that make sense or no? Yeah? Okay. So, a couple things from here. The red one is going to be the slope, so I can find the slope at any point. So I know if the red line crosses the x-axis here, that means the slope at this point is 0. The slope right here is also 0. So slope here is 0, slope here is also 0. And so I could actually draw my tangent line right there for being 0.
And the minimum for your derivative, is that just like a guess, or is there like?
What do you mean? Right here?
Yeah.
Yeah, basically.
Okay.
Taking a guess on it, because right there, if it's that, could do the math on it, but I really don't want to. But yeah, that's just guessing on it. Because give it a graph, you have to do a recursive to actually be able to find it. All right, questions? So I wanted to get through a certain amount. I'm good. All right, so you guys should be good for today's assignment. So we'll pick up here tomorrow. All right, don't forget, like, share, and subscribe. Hit the notification. Hopefully I get more.